Whales are endangered from a variety of threats, most of which are the direct result of human activities.
Century, many of the large whale species were hunted almost to extinction by commercial whaling. Though some of those species are now recovering, the hunts are still banned in many areas of the world. Although many efforts are being made to aid in the restoration of the whale population, a newfound threat may stop its progress. Early in the morning of Friday, February 9th, 2017, a group arrived at the isolated Farewell Spit on the coast of New Zealand, only to discover the devastating sight of over 400 beached pilot whales. New Zealand's Department of Conservation had spotted a large pod moving towards the coast overnight, but by the time anyone arrived on the site on Friday morning, over 300 of the whales were already dead. The community sprung into action and over 500 volunteers turned out to assist with the rescue effort, but the drama wasn't over. On Saturday afternoon, a second pod of over 200 pilot whales hit the shore, turning this into the second largest mass stranding of whales in New Zealand history. Data shows that there has been a 25% increase in reported strandings in the UK since it began keeping records around 25 years ago. Experts had long believed that sonar played a central role in causing whales to strand, but there are new theories being researched that challenge the traditional view of whale beachings. Just days before the historic mass whale stranding in New Zealand, NASA heliophysicist Antti Pulkkinen announced a new study was being launched to investigate whether solar storms could be a major factor behind these baffling natural tragedies. Pulkkinen suspects that magnetic anomalies caused by coronal mass ejections from the sun could have a disorienting effect on animals that rely on magnetic field sensing for navigation. Surges of solar activity may cause whales to run aground, possibly by disrupting their internal compass. Researchers Dr. Klaus Vanslo and Dr. Klaus Reichleff published their study in an issue of the Journal of Sea Research. The scientists looked at sightings of sperm whales beached in the North Sea between 1712 and 2003. They then compared this record with astronomers' observations of sunspots, an indicator of solar radiation.
More whale strandings occurred when the sun's activity was high, they found. The sun experiences cycles of activity that range from 8 to 17 years, 11 years being the average.
Numerous other explanations have been proposed as well, with some suggesting the use of multibeam sounders and other instruments used to map the seafloor or locate potential fishing sites, or messing with the whale's internal compasses. However, these human-made influences do not explain most of the strandings, says NASA heliophysicist Antti Pulkkinen. Theories as to the cause include magnetic anomalies and meteorological events such as extreme tides during a new moon and coastal storms, which are thought to disorient the animals. It has been speculated that due to the possible magnetic field sensing used by these animals to navigate, magnetic anomalies could be at least partially responsible. During a solar storm, the sun ejects giant bubbles of charged particles. This is known to interfere with Earth-orbiting satellites and power grids as the particles slam into the magnetosphere. Solar storms have been happening since the creation of the sun. A solar storm, or flare, is a violent explosion of magnetic energy on the sun. A coronal mass ejection, or CME, is a billion-ton cloud of gas exploding from the solar surface. Scientists can detect these solar storms and measure how Earth's environment changes. Storms from the sun sometimes make their way to Earth. Solar flares produce high-energy particles and radiation that are dangerous to living organisms. However, at the surface of the Earth, we are well protected from the effects of solar flares and other solar activity by the Earth's magnetic field and atmosphere. Solar astronomers have been trying to answer this very good question for a long time and still don't know exactly what causes flares in the 11-year solar cycle. Flares are caused by the explosive release of magnetic energy on the sun. There are more flares when there is more of this magnetic energy around. Every 11 years, the magnetic energy increases, and this causes an increase in the solar flares. So that is part of the answer, but we still don't know why this magnetic energy increases every 11 years. Besides flares, magnetism on the sun causes sunspots. So when there is a lot of sunspots on the sun, you can expect more flares. Astronomers actually count the sunspots every day and make graphs of the sunspot number. It shows the 11-year cycle very clearly. In fact, astronomers can count sunspots before they even realize that the flares happened. So we have these sunspot numbers now for over 200 years. It's a long-standing mystery, and it's very important that we figure out what's going on. The study is expected to run through September and could provide new insight on the mysterious phenomenon that is whale beachings. The result of the study will be informative for researchers, stranding network organizers, research agencies, and regulatory agencies. If we understand the relationship between the two, we may be able to use observations of solar storms as an early warning for potential strandings to occur. This will allow stranding responders in global hotspots and really around the world to be better prepared to respond, thus having the opportunity to save more of the whales.
Another way that we can help the whales that have become beached is to have responders and organizations ready at the hot spots of whale beaching, which are New Zealand, Cape Cod, and Australia. Having responders will help lower the death rates of the beached whales while research is still being done to solve this phenomena of whale beachings and solar storms.